Okay, we are on the PowerPoint for Chapter 18, Slide 9, question number 2, which reads, what mass of ammonium chloride would have to be added to 500 milliliters of 0.1 molar ammonia to give a solution with a pH of 9.10? Well, this is going to be an acid-base buffer question. This is going to be your conjugate acid in the buffer, because when I dissolve ammonium chloride in solution, it dissociates to ammonium ions and chloride ions. You never have to worry about chloride ions when it comes to pH. So really, we're looking at this equation. The pH is going to be the pKa of ammonium plus the log of the ratio of the conjugate base, which is ammonia, to conjugate acid, which is going to be ammonium. And you might remember in the last problem, we showed that the Ka for ammonium is 9.26. So let's see. I know pH. I know the pKa. Sorry, this should be pKa, not Ka. This is the pKa. And I know the concentration of ammonia. So this is the only thing that I don't know. All right, so let's dig in here. So I'm going to subtract the pKa from both sides of this equation. So if I do that, this cancels, and I get whatever the pH is that I'm looking for, which we have up here, minus the pKa. That's going to be equal to the log of the ammonia concentration over the ammonium concentration. All right, looks like I'm going to need to take the inverse of the log on both sides of the equation. So I want to take 10 to the power of whatever pH minus pKa is, and 10 to the log of this. So this is going to cancel, because these are inverse functions. And that leads to 10 to the pH. Let's just figure out what that is. pH minus pKa for this problem. pH minus pKa. This is going to be 9.1 minus 9.26. 10 to the negative 0.16. That's pH minus pKa. That's going to be equal to the ammonium concentration that I'm looking for. Oh, sorry. That should be ammonia. I messed that up. Ammonia concentration over ammonium concentration. Okay, what am I going to do now? I think I'm going to multiply both sides of the equation. Here, let me write this down here just a little bit. 10 to the negative 0.16 is the ammonia concentration over the ammonium concentration. Let's multiply both sides by the ammonium concentration. And I'll need to multiply this side by the ammonium concentration. And if I do that, I'll get the ammonium concentration times 10 to the negative 0.16. That's going to be equal to the ammonia concentration. This is what I'm looking for. So I'm going to divide both sides by 10 to the negative 0.16. And I've got an equation that the ammonium concentration that I'm looking for should be the ammonia concentration, which is going to be 0.1 molar, divided by 10 to the negative 0.16. Well, I can figure that out. Let's see, 0.1 divided by the quantity 10 to the power of negative 0.16. So it looks like the ammonium concentration that I'm looking for is 0.145 molar. Now let's make sure I've answered the question. Oh, I haven't, because they're looking for the mass of ammonium chloride that I'm going to need to add to 500 mils, basically to give this concentration. So I'm not quite done. Okay, so let's see here. This means I have 0.145 moles of ammonium that I'm going to need for every liter, but I only have 0.5 liters. Remember that? 500 milliliters. And I want to know what mass. So let's see. 1 mole of ammonium. How many grams is that? Let's see. Nitrogen, that's 14. And then hydrogen, that's going to be 4 times 1. Oh, and they asked for ammonium chloride. That's a good thing I remember that. I'm going to have to add ammonium chloride. So let's see. That's going to be chloride as well, which is 35.5. Let's see, 14 and 4 and 35.5. Before I do all this, I think I'm skipping some steps for some folks. So make sure you recognize for every 1 mole of ammonium, that's going to come from 1 mole of ammonium chloride. And then from this math here, we see that 1 mole of ammonium chloride is how many grams? I hope I did that right for chlorine. Yeah, I think that's right. 53.5 grams. Just check real quick. Hey Siri, what's the molar mass of ammonium chloride?
The answer I found is 53.004 atomic mass units.
Alright, so they're using 53. We'll just use 53 like Siri told me. It's close enough. Alright, it's time to do the math here. 0.145 moles of ammonia per liter, but I'm only doing half a liter, 1 to 1. So 1 mole of ammonium for every mole of ammonium chloride, and then I need to multiply this by 53. Oh, what did I do? 0.145 times 0.5 times 1 time 53. 3.84 grams of ammonium chloride are going to be necessary. What's it necessary for? Well, I'm going to have to add that much. I'm going to have to dissolve that much ammonium chloride in 500 mils of 0.1 molar ammonia to give me a buffer with that pH.